Okay, so this section is 1.3 other types of geometry. So we're going to start off with some definitions here. So go through and write those different definitions down from the book. So the first one there is pixels, so that's on page 20. So if you look at that, that says tiny dots on a computer screen. So if you've got, your phone screen, your computer screen, iPad, whatever you've got, that's made up of a bunch of tiny little dots, and each one of those are called pixels. Okay, so that's going to go with one of our types of geometry. And the next definition here is discrete geometry, and that's what pixels actually fits with. So discrete geometry is, it says for a description of a point is called a dot in discrete geometry, and then description of a line is a set of dots in a row. Okay, so when we're talking about discrete geometry, a line is basically a bunch of dots in a row like that. Okay, so that's what they consider a line in discrete geometry. A good example of this would be like if you think of old scoreboards at like a football field or a baseball field or in the gym, when they had those old light bulbs representing the numbers where, they've got the 8 and it kind of has got something like that kind of boxy shaped where they use light bulbs for all of those little numbers there. That would be an example of discrete geometry because you're making lines out of a bunch of dots or a bunch of light bulbs. So the next four kind of go together here. So we've got arcs, network, graph theory, and then nodes or vertices. Okay, so these all go with graph theory. So I'm going to start with graph theory, and that is on page 21. It's also on page 22. I'll probably change that to page 22. There's a better definition on page 22. So on page 22 for graph theory, it says a point is a node of a network. So node here goes with graph theory, so that's what a point is. And then description of a line is an arc connecting either two nodes or a node to itself. Okay, so I'll give you a picture of graph theory. So graph theory, say we've got some points, maybe something like that. So each of those points would be called a node. So those points are nodes. And then the lines that connect those nodes are what we call arcs. Okay, now these arcs don't have to be straight. Okay, so a lot of times when we're dealing with lines, we want them to be straight. In graph theory, your arcs don't necessarily have to be straight. They can be kind of curved like that. Okay, and you can have multiple arcs going to multiple nodes like that. Okay, so this would be a picture of graph theory, and then this whole picture together is what we call a network. So if we're talking about a network being traversable, this is what a network looks like. So each of those little points there is a node, and then each of the curved lines, and they could be straight lines as well, those are called arcs. Okay, so nodes and arcs. And that whole geometry together is graph theory. So discrete geometry, bunch of dots making a shape, graph theory where you have nodes and arcs connecting those nodes. Okay, so the next thing here, there's an activity in the book, Activity 1, wants you to trace the picture and try to find a path across all 7 bridges exactly once. So there's a picture of a bridge on page, what page is it on here? Page 21. They've got a picture there. I think the easiest one to look at is this one here. And basically what they want you to try to do is go to each of these nodes here is like an island or a piece of grass, so kind of up here. What they want you to do is they want you to try to walk to each of these points, considering these like bridges. They want you to walk to each one of those points and all the way around, crossing every single line without picking up your pencil. Okay, so you've got to get to each one of those points and over all of those bridges without picking up your pencil. So pause your video, see if you can figure that out, and then come back and I'll explain the answer to you. Okay, so basically what ends up happening there with that activity is there's actually no possible way to go to all of those points without crossing one of the bridges twice. Okay, so there's actually no possible way to do that in that bridge problem. And I'm going to explain to you in this section why that happens. Okay, so to go along with that, the next definition there is traversable network. So if you look on page 22, they have traversable. So what traversable is it's basically, without lifting a pencil off the paper, can you trace over all of the arcs of this network exactly once? So going back to this problem here, we couldn't go through and go over every single one of those lines without picking up our pencil, so that would be considered not transversable. Okay, so traversable is when you can do that, so maybe you had just like a square or something like that. Well, if you started there, you could go around all of those sides without picking up your pencil. That would be traversable. If it was something like this, where you could try and nothing works, that would be not traversable. Okay, and then graph theory, we already wrote the definition down up there, so I'm not sure why it's in there twice, but graph theory is basically just where you've got the arcs and nodes connecting together to make a network. Okay, so this example here, basically what they want us to do is they want us to see how many arcs are at each node of the network. Okay, so again, our nodes are our corner points here. So what they want us to do is they want us to go around to all of those and see how many nodes are there. So, like if I just write the letters here, G, H, K, F, and J. Okay, so if I look at G, looking at that node, I want to see how many arcs are coming off of it. Well, I've got an arc right here coming off of it. I've got an arc right there coming off of it. So I would say that there's 2 arcs coming off of G. Okay, next one, H. I've got 2 arcs coming off of H. Off of K, looks like off of that I've got 2 as well. Next one, F. So it looks like off of F I've got 1, 2, 3 arcs coming off of F. And then off of J, 1, 2, 3 arcs coming off of J as well. Okay, so that's all they want you to do for a problem like that. See how many arcs are coming off of each one of those nodes, and we did that there. Okay, so same thing for B. They want us to do the same deal, so I'll write my letters O, L, P, N, M. Okay, so if we look at O, it looks like 1, 2, 3 arcs are coming off of O. L, that node, we've got 1, 2, 3 arcs coming off of L. P, it looks like 1, 2, 3, 4 coming off of P. N, we've got 1, 2, 3. And then off of the node M, 1, 2, 3 off of M. Okay, so all 3s except for P, which is 4 arcs coming off of P. Okay. Page here. Okay, so the next thing, activity 2, so on page 23 it says use example 1 on page 22, and what's it say here? I have to read back to it. So activity 2, okay, so it says look at the networks in example 1, where must you start and end in order to traverse network 1, where must you start and end in order to traverse network 2, and then for 3, is it possible to traverse network 3? Okay, so for the first one, basically they want you to see where you need to start and where you need to stop to be able to go around this whole shape without picking up your pencil. So like maybe I start at A, go down to B, then C, then I go up all the way to A. Well, I went too far because I didn't get out to D there. So maybe I start on A again, go to B, C, maybe I go to E, but then I go back out to D. Well, then I still need to get this part here, and I didn't cover that, and I didn't cover that part there. So try that out, see if you can figure out the path that'll get you all the way around there, and then write down where you started and where you stopped. Same thing for the second one there in the picture. Go through those and see where you need to start and where you need to stop to be able to get around that. And then for the last picture, they just want to know if it's traversable or not. So if you can go around without picking up your pencil and touch all of the arcs and all of the points without crossing back over the arcs as well, then it would be traversable. If you can't do that, then it's not traversable. Okay, so try that out, and then I'll get you the answers to that. Okay, so the answers for activity 2 for the first one, basically you can either start at D or B and end at D or B. Okay, so if we start at D, go around there, maybe we go to D, then we go to B, and then C, and then back up to A, and then back to B. So that would work. So D, we went down straight there, over to C, up to A, and down to B. That covers them all. Or maybe we start at B, go up to A, to C, back to B, up to D, that would hit all of our lines once. So we could either start at D or start at B, and then our stopping place would be one of those two as well. For the second one, let's see, so we, what's it say here? We could start or end at any point. Okay, so if we start at F, and we go around here, so F to I to G to H to J, well, we end back at F. If we start at I and go around there, we end back at I. So wherever you start on this one, you end in the same place. So your starting node could be at any point, and then your stopping node, it's going to end at the same point that you started at. So if you started on F, you're going to end on F. If you start on J, you're going to end on J for that one. Okay, so both of those networks would be traversable because we can go all the way around to all of those arcs without crossing back over any of the arcs and without picking up our pencil. Okay, so now for the last one here, they want to know if this is traversable or not. So out of all the different options that you try, this would end up being not traversable. Okay, so you can't, there's no way to go around this shape here to hit all of the arcs without picking up your pencil and without crossing over anything twice. So this one ends up being not traversable. Okay, on to the next thing here. So there is actually a trick to how this works where you don't have to use the whole pencil method. So kind of the little trick here, and I would probably, put a star by this when you write it in your notes, is whenever a network has more than 2 odd nodes, it is not traversable. Okay, so what an odd node is, so say we've got a point here, and we've got an odd number of arcs coming off of it, that would be not traversable if there's more than 2 of those. Okay, so this would be an odd node. Oops, odd node. So if there's more than 2 of those, then it's not good. So you can have up to 2, but once you hit the third odd node, then you're out. Okay, so it's like 3 strikes, you're out. You're good with 2 strikes, so you're good with 2 odd nodes, but once you hit that third one, then it's not going to be traversable anymore. Okay, so if we look back to our ones we just did here, if we look here, so we've got A, that would be an even node because there's 2 coming off of it. E is even because there's 4 coming off of it. D is odd because there's 1. C is even, and B is odd. So if we look at those, we've got 2 odd nodes, so 2 is okay, but once we hit that third one, then we're not okay, but this one would be good. This one would be traversable because it's only got 2 odd nodes. Okay, if we go to this next one here, we've got F, 2 coming off of that, so it's even. I, 2 coming off, so it's even. J, 4 coming off, so that's also even. G is even with 2, and H is also even with 2. So since all of those are even and we have 0 odd nodes, that would be less than 2, so we're good. Okay, now this last one here is not traversable, and I'll show you why it's not traversable. So if we look at K, you've got 1, 2, 3, that would make it odd. N, 1, 2, even. M, 1, 2, 3, that would be odd. L, 1, 2, 3, that would be odd. And P, 1, 2, 3 coming off of that. So this one has 4 odd nodes, so since it has more than 2 odd nodes, it's a no-go, it's no good. Okay, so you're good at 2 odd nodes is okay, but once you hit that third one, then it's not traversable. Okay, so that's a little bit easier than going around and using your pencil. It's a little more surefire way of getting that right. Okay, so back to example 2 here. They basically want us to figure out if these are traversable or not. So if we look here, I would take and figure out if these are odd or even nodes. Okay, so if I look at T, I've got 1, 2, 3 coming off of T, that's odd. 1, 2 coming off of S, that's even. R has 1, 2, 3, that's odd. U has 1, 2, that would be even. So I've got 2 odd nodes and 2 even nodes. So with only 2 odd nodes, I'm still good to go. Okay, once I hit that third one, no go. But since I only have 2, I'm good to go. So this would be traversable. And then your explanation would be that there's only to odd nodes.